We need some help with this one, then maybe we can do it ourselves. We think. All right. First element is magnesium. If you look up the other one, the SO3, it is sulfite. And the next one is magnesium, but it's sulfate. ATE is the maximal number of oxygens, and ITE means it's one less, right? So this is sulfate, this is sulfite. Now what's different about this one?
Lead.
You need a Roman numeral, don't you? Because it's lead. It's even though it's not truly in a transition metals, it's underneath down there, so it needs a Roman numeral. So how are we going to decide the Roman numeral? Well, this PO3 has a charge of 3 minus. And how many of, and this is phosphite, right? So, how many phosphite ions do I have? How many phosphite ions do I have? I have 2, don't I? This 2 tells me I have 2, everything that's in there. So times 2, I have 6 negative charges. Everybody agree with that?
Yeah.
That means I have to have 6 positive charges, don't I? They're going to be spread, do that in different color. They're going to be spread over 3 leads. So each lead is 2 plus. This is lead 2 phosphite. Okay? You got it?
I got it.
Look at that smile. That's awesome. That's why we teach right there. That absolutely is why people teach.
All right.
When a student gets it. All right, well, here's 3 more for you to do then. You ready? First one's the toughest one. This guy right here is sulfate, right? SO4, 2 minus. And how many do we have? 3 of them. So we have 6 negative charges. We have 2 irons, so we divide 6 by 2. That means that each iron is 3 plus, right? Ooh, it's a 3. This is iron 3 sulfate. Now this one's a little bit easier because barium doesn't need a Roman numeral, does it? It's in group 2. So it is barium phosphite. All right, and the last one? Well, this is CO3 2 minus, right?
Yes.
So that must mean that this is 2 plus. So this is nickel 2,
Carbonate.
2 carbonate. Now somebody asked me in the other class, well, wait a minute, why is that in an ATE when there's only 3 oxygens there? Whereas these in an ITE when there's 3 there. Yeah, that's not a hard and fast rule, okay? This is carbonate, that's sulfate, and phosphate would be PO4, right? So don't try to remember how many oxygens are there and put the 8 on there. That's not the way that works, okay? Everybody understand that?
Yes.
Okay, use that chart.
You just need to use a chart?
Use a chart. Don't try, I mean, you can memorize the chart if you want, but use the chart. Like when we have the midterm coming up in a few weeks or whenever that's going to be, I got to sit down and look at the calendar and figure out when we're going to do that. All the snow's got us all messed up. I'll give you a chart for the polyatomic. I'll give you that on the test, right?
Okay. So are the midterms not all the same week? Because I have a biology one next week. So.
I can do it whenever I want. my class, my rule. I'm the dictator here. I think I'm fair and just most of the time. What the heck? Is that all? I thought there was more examples. I guess not. Okay. So, that finishes up ionic compounds. That was a good review for ionic compounds.
Yeah.
So, not all compounds are ionic though. Some are what we call molecular or covalent. Okay? Ionic compounds are ionic because they transfer electrons. I give you my electrons, I become positive, you become negative. But what if we don't want to give them up? What if we want to share them? We share my electrons in between the two of us, so we both get to count them? That's better, huh? No? Yeah, sometimes. Some elements do that, okay? And those are called molecular or covalent compounds. How many do they share? They share enough so that they still achieve an octet. Just like ionic compounds were formed so that they had a full octet, right? They either gained or lost electrons so that they had a full valence shell. Right? Same thing happens. Atoms of two nonmetals come together and share electrons. Key here, two nonmetal atoms come together. There's no metals here. Only nonmetals, okay? There are no charges here. These are not ions, okay? They still share enough to where they get a full valence shell though. They still want to look like a noble gas. So, here we have hydrogen. And I'm going to draw hydrogen. And I'm going to draw, remember in the last chapter we did some things that look like that? Dot diagrams, Lewis dot diagrams. Y'all remember that a little bit? What if I have two hydrogen atoms like this? Now, how many valence electrons does hydrogen want to have is the question. It's tiny. What's the closest noble gas to hydrogen? Helium. And how many valence electrons does helium have?
2.
Only 2. So hydrogen only needs 2 to be happy. So what if these two hydrogen atoms said, hey, let's get close enough where we can share these electrons in between. And now watch this. I can count these, and you can count these. We're going to share. Sharing's caring. They share. It's a good, happy relationship, right? Because they both get to count the kids, tax deductions, and they have a full octet. In this case, a duet, because they want to look like helium, because they're small. Okay? Fair enough? And we would often draw that, instead of drawing 2 dots there, we would draw a dash in between. This dash, 2 electrons. It is a bond. Okay? So when you see something drawn with dashes like that, it means there's a bond there. There's 2 electrons, and both of these guys are being held together. Why are they held together like this? It's my other analogy, I like this. What do we have over here in the nucleus of this hydrogen? We have a proton that's positive. And what do we have in the nucleus of this hydrogen? We have a proton that's positive, right? Well, if there weren't any electrons between these 2 nuclei, what would happen to them? They wouldn't bump into each other. They're both positive. What would they do to each other? They would repel each other. So why are they held together? Because they're both attracted to the electrons that are there. Here comes the analogy. What holds most families together? Electrons are like children. Mom and dad are repelled by each other. It's only the children that hold them together because they're both attracted to the children in the middle. That's a sad analogy, isn't it?
So sad.
Yeah.
So sad.
That one's better.
Huh?
Let's hope it's not all reality.
Yeah, I got another one later on that's pretty good too. Here's their drawing of the same thing. Here's fluorine. How many valence electrons does fluorine have?
7.
It has 7. It's a halogen, right? When you look at this, look right here. What do you see when you look at that diagram? I see a lone dot that looks lonely, right? So what do you think's going to happen? This guy has a lone dot that looks lonely too, doesn't it? They're going to pair up, and we're going to form this. Just like hydrogen, it's positive, positive, and we got electrons in the middle holding them together. The two nuclei are positive. The two nuclei are attracted to these electrons in the middle, holds them together. Single bond, one pair of electrons there. Okay? Now, there are 7 elements that come together to form what we call diatomic molecules. Everybody knows that when you see somebody with an oxygen tank, it is O2, right? Okay? All of these elements exist naturally like that. We say that they're diatomic. So when I tell you oxygen is reacting with hydrogen, that means O2 reacts with H2, okay? Not O plus H. Okay, so in the next chapter we're going to learn about writing equations and stuff. So, there are 7 elements that do this. Here's how you remember this. It's on the periodic table. The number 7 plus hydrogen. So you have nitrogen, oxygen, fluorine, chlorine, iodine, bromine. Sorry, chlorine, bromine, iodine. Plus hydrogen. So across the top, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Then hydrogen. So 7 of them behave as diatomic molecules. All of these have equal sharing of the electrons, right? And they exist together like that, with 2 of them together. You'll never find one oxygen atom by itself. It'll be bonded to another one, or it'll be bonded to something else. Okay?
So diatomic means that
That there are 2 atoms in this molecule. Okay? These 7 elements exist like this. N2, O2, F2, H2. You don't ever find just hydrogen by itself, one hydrogen atom. Doesn't work like that. Because it's too reactive. It wants to fill that valence shell. Okay? So,